Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Centipede O with a lot of arrows. Maybe it's just O with a lot of arrows. It doesn't have that many O's. It just has one O, so maybe it's just O. Centipede O. And it's by Will Power. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have Renban, where numbers on the purple line are a set of non-repeating consecutive numbers in any order. So you could have something like, say, 2, 4, 3, 5, and 3. And this would be a valid Renban because 2, 3, 4, 5 are a set of consecutive non-repeating numbers. And that's an example of how Renban works. We also have arrows, where numbers on arrows sum to the number in the arrow circle. So say this was 2 and 6, then this would have to be 8, because the digits along the arrow must sum up to the circle that it's digit that's in the circle that's attached to it. And that's an example of how arrows work. We also have crop key pairs, where numbers with a black dot between them are in a ratio of 2 to 1. And not all possible dots are shown. So, for example, if this were, say, a 2, this would have to be 1 or 4 to maintain the 1 to 2 ratio between them. And that's an example of how crop key pairs work. And finally, we have killer cage, where the numbers in the cage sum to 30. So these 5 digits must add up to 30. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Couple of interesting things is the sum of these two digits equals the sum of this digit here. So therefore, these must form an even. These will be adding up to an even sum because this is equal to, these two sum up to this digit. So therefore, this is equal to 2 times this digit, which is an even digit. So since this is even and this is even, this must be odd. 9 can never be on an arrow part unless if it's adding with another number, another digit to add up to another digit. Right? Because 9 plus no other digit in normal Sudoku, I should say. 9 plus another digit is not going to be another digit, right? So this is 1, 3, 5, and 7. This can be 3 because 1 and 2 and 3 adds up to, but this can't be 9. So if you have 1, 2, 3, that's 6, plus 30 is 36. 45, which is the sum of the digits 1 through 9, minus 36 would be 9 here, but this can't be 9. So this cannot be 3. This could be 4, in which case this is 7 here. 4 and 1 and 3, and that's 7, so that's fine. Or 5 could be here, or 6, or 7. And that's the most, right? 7 plus 7 is 14, plus 30 is 44. 44 plus 1 would have to be, would add up to 45. So this is 4 through 7 here. This digit is the sum of 2 digits in a 1 to 2 ratio with each other. So it could be 1, 2 here, which forces that to be 3. 2, 4, which forces that to be 6. And 3, 6, which would force us to be 9. But we know that 9 cannot be next to a black crop key dot, because if you have 9, you get 4.5. If you double 9, you get 18, neither of which are digits. So this is 3 or 6, which forces this to be 3 or 6, which eliminates 3 and 6 in the rest of the column and the rest of the box. So this can't be 3 and 6. Well, so since this can't be 6, you can't... Okay, that makes sense. 6 and 6 adds up to, well... 6 and 6 adds up to 12, plus 30 would be 3. 4, okay, so can you have 5 and... 5 doesn't work, because if you have 5 here, 5 and 5 is 10. 30 and 5 would require to be there. So this cannot be 5, this can't be 5. So either this is 4 doubled this way and 7, or this is 7 doubled and this is 1. Either way, a 7 is guaranteed to be here. This is either, again, 3 with adding up with 1 or 2, and this is 6 with 2 or 4. Either way, there's guaranteed to be a 2 here. If this is 4, this would be 7, and this would have to be 1. So you'd have 1 and 3 there if that's 4. If this is 7, so if this is 4, this is 3 and 1. If this is 7, it could be 1, 6, or 3, 4. We have a 1, 4, 7 triplet now in row... Right, a 1, 4, 7 triplet in row 8, which eliminates 1, 4, and 7 in the rest of the row. So this is guaranteed to have 2, 5, 8, 9. And the last digit is either 3 or 6. We know 1, 4, and 7 add up to 12. 30 plus 12 is 42. 45 minus 12 is 3. So this is 3, this is 6. Which means this is 2, 4 as a pair. So again, if this is 4, this is 1, 3. But this, okay, so this 2, 4 means this 1 to 2 ratio cannot contain 2 or 4. Well, that eliminates 1, 2, 2, 4, and 4, 8. The only remaining pair then is 3 and 6, which eliminates 3 in the rest of the box. So this can't be 3, therefore this can't be 4, with 1 and 3 being there. So this must be 7. So this is 7, which makes this 3 and 4. This is 1, which means this can't be 1. This has to add up to 7. Cannot be 1, 6 because 1 and 6 are in the box already. Could be 2, 5 if this is 2 and this is 5. Cannot be 3, 4 because 3 cannot be in either cell here. So this is 2 and this is 5. So these 2 and these 2 add up to this digit here. Remaining digits left are 4, 5, 8, and 9. Okay. This can't be 4. 9 cannot appear on any of the arrows, like we said, because if it adds up with another digit to add up to another digit. So this is 9 here. This must be 1 and 8, and this has to be 4 and 5 here. This can't be 5, so this is 4, that's 5 there. This is in a 1 to 2 ratio, and it cannot contain 1, 8, 3, or 6, so it must be 2, 4 as a pair. Because 5, 7, and 9 cannot be next to black crop key dots. So this must be 5 or 7. This is 5 or 7. This 5 in the box eliminates 5 here. So this is 7. That's 5. Remaining digits in column. Well, let's do remaining digits in box 4. We have 1, 8, and 9. Actually, any of those could be 1, 8, 9. Remaining digits in column 3, we have 1, 7, 8, 9. Obviously, 1 can't be here. 9 cannot be along the arrow add up with another arrow. This cannot be 5 and 4 adding up to 9, so this can't be 9. We have a 1, 7, 8 triplet in column 3, which eliminates 1, 7, 8 in the rest of the column. This can't be 1 or 8. It's 9, which eliminates 9 here. This cannot be 5 plus 2 adding up to 7, so it's 5 and 3 adding up to 8. So this is 8, which eliminates 8 here, no 8 here. Remaining digits in column 2 then are 6 and 9. Okay, these two digits add up to 6 and they can't have 2 and 4, so this must be a 1, 5 pair. Remaining digits next to, or in row 7 are 3, 4, 7, 9. Again, 7 and 9 cannot be next to a black Kropke dot. So 3 would have to force 6 to be there. 4 would make this 2 or 8. 9 cannot be on the arrow. This is a 1 to 2 ratio without a 4. So it could be 1, 2, 3, or 6. 3 can't be here, so 6 can't be there. This is the sum of two unique digits. Sorry, two digits in a 1 to 2 ratio. So it's either 1, 2 adding up to 3, or 2, 4 adding up to 6. And this could actually be 9 also. So 3, 6, or 9. And this is 1, 2, 2, 4, or 3, 6. This can't be 3 though, so this can't be 6 there. 9 has to be one of these 3 though, because it can't be along the arrow in box 5. 9 cannot be here either. 9 can't be here because it can't be again next to a black Kropke dot. So 9 has to be one of these digits, which means this Renban is a 6, 7, 8, 9 Renban, which eliminates 6, 7, 8, and 9 in the rest of the box. So this has to be in a 1 to 2 ratio with 2 other unique digits without an 8 being here. So this must be 2, which makes this a 1, 4 pair to be in the 1 to 2 ratio. Therefore, this is 3 and 5. This 1, 2, 4 pair eliminates 1 and 4 in the rest of the column, so this can't be 4. You cannot have a 7 here because 7 with 1 adds up to 8. And 7 with 2 adds up to 9, but we don't have 1 or 2 available because of the 1, 2, 4 triplet in the column. So this has to be 3, which makes this 4. No 6 here, no 3 or 4 here, no 3 or 4 here. This cannot contain 1, 2, or 4 here, and this can't add up to 9, so therefore this must be 3 and 5, adding up to 8. So this is either 2, 6, or 1, 7. We're not sure which. This 2 eliminates 2 here, so that's 4, which makes this 2. This cannot contain a 2 in a 1 to 2 ratio, cannot contain 3 because of the 3, 5 pair in the 1 to 2 ratio, so this must be 4 and 8 to be in a 1 to 2 ratio, which eliminates 4 and 8 in the rest of the row. This can't be 4, it's 1, which eliminates 1 here, so it's 4. This can't be 4 anymore. This 1 eliminates 1 here, so it's 7 and 1. That leaves this digit as a 6 or a 9. Okay. So this can't be 4. That and well, this could be 4 here. That's fine. Okay, remaining digits in column 9 are 6, 7, 9. This can't be 7 or 9 because of 7, 9 in the column, so this is 6, and this forms a 7, 9 pair. We are guaranteed a 5 somewhere in row 4. So 5 has to be one of these 3. If this is, that could obviously be 5. If this is 5, it has to add up with another digit to add up to something greater than 5, and it can't be 6, 7, or 9. It would have to be 8. So this has to be 5 or 8 here. If this is 8, this is 3, 5. If it's 5, though, it could be 1 through 4. Okay. Hmm. This cannot be 1 and 2 added together, because if this were 1 and 2, this would not be able to form a 1 to 2 ratio with this digit, because you'd have 1 or 2 here, but you have the other 1 or 2 here, and you'd have 4 here. So this cannot be 3, cannot be... can't add up to 3, can't add up to 4, 5, so this is 6, 7, 8, or 9 here. Hmm. Mm-hmm. Remaining digits of row 8. We have 2, 6, 8, and 9. Obviously, 8 cannot be any of these digits. Where is the 1? 1 has to be here. So this must be a 1, 7 pair, which eliminates 1 and 7 in the rest of the box. This can't be 7. It's 9. This can't be 9. So it's 2, 6 as a pair, which eliminates 2, 6 in the rest of the row. This 9 eliminates 9 here, so that's 7. This must add up to less than 8, and it cannot have a 7 here. Where is the 7 in row 3? Can't be any of these digits because it can't be next to a black crop key dot. It can't be here because of 7 in the column. So 7 has to be here. So this is 7, 9 as a pair, which eliminates 7 and 9 in the rest of the box. 9 eliminates 9 here. So that's 7, that's 9. The 6, 8 pair eliminates 6, 8 in the rest of the row. So this can't be 6. It's 9, which eliminates 9 here. So it's 6, which forces this to be a 9 here, which means this cannot be 9. Where is 9 in this box 5? Again, it cannot be on the arrow parts if it adds up with another digit to add up to a single digit. And it can't be here, so it must be here. It can't be here because of 9 in the column. This is then 9 equals 3 plus 6. That eliminates 6 from being here and 3 from being here. This becomes a 1, 2 pair here. This 1, 2 pair eliminates 1 and 2 in the rest of the column. This can't be 1. It's 5, which eliminates 5 here, so that's 1. 9 eliminates 9 here, so it's 8 and 9. 8 eliminates 8 here, so it's 4 and 8, which eliminates 8 here, so this is 5. So this must be the sum of 1 through 4 here. This is then 3 or 4. This cannot be 2 and 3 adding up to 5, so this must be a 1, 4 pair, which eliminates 1 and 4 in the rest of the row. This can't be 1, it's 2, which makes this 1, which makes that 2, so this is 2 and 3 adding up to 5. This 1, 4 pair also eliminates 1 here, so it's 8 and 1. So 2 and 4 add up to 6, but we can't have a 4 here because of 4 in the column. 2 and 5 add up to 7, but there's no 5 possible here, so this must be 2 and 6 adding up to 8. Which eliminates 8 here, so that's 2. 2 eliminates 2 here, so it's 4 and 2. 6 eliminates 6 here, so it's 3 and 6. 9 eliminates 9 here, so it's 7 and 9. This adds up to 9, but it cannot have 1, 2, or 3, so it must be 4 and 5. And 5 can't be here because of 5 in the column, so this is 4, that's 5. That leaves this as a 1, 7 pair. And 7 cannot be here because of 7 in the column, so this is 1, that's 7. 4 eliminates 4 here, so it's 1 and 4. 5 eliminates 5 here, so it's 3 and 5. 2 eliminates 2 here, so it's 6 and 2. 1 eliminates 1 here, so it's 7 and 1. 6 here eliminates 6 here, so it's 8 and 6. Remaining digits. We can probably just, yeah. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. 2s, we have 8 2s. We know where the last 2 is. 3s, we have 3 in row 6 has to be here. And that gives us 8 3s, so we know where the last 3 has to be. It has to be there. We have 9 4s. We have 8 5s, so the last 5 has to be there. We have 8 6s, the last 6 has to be there. We have 8 7s, the last 7 has to be there. We have 8 8s, and the last 8 has to be there. And that's a solution. Yeah, kind of interesting. The arrows forcing this to... I don't really use this, though. I just sort of basically spotted what... It was just basically this was the break-in, right? And then everything else sort of flowed from that. I guess it was this part too, right? I don't know. I mean, it seemed fairly straightforward. Yeah, not quite very easy because it was always just a little bit more difficult than very easy, but not too bad. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.